All right, so today we're going to go ahead and start off by looking at solving equations. Our focus for today is we're going to be solving one-step equations. So what we are going to be doing is we are going to be solving, right? The title of our lesson today. We are going to be solving equations. We're finding a solution to something. We are finding out what is the value of our variable. As we get further and we start looking at multi-step equations, we will be simplifying first and then solving. We'll need to combine all of our like values, our like terms first, and then we'll go ahead and solve it. But simplifying is just, again, putting something in the simplest form possible. And then evaluating, which we're not focusing at all when we're solving equations here, but it's substituting in a value, a numeric value into an expression, and then simplifying using order of operations. Before we can get started, we need to talk again about order of operations. We've already looked at order of operations where we evaluated expressions. We found out what the numeric value of that simplified expression would be. But now we're solving things. Order of operations is still important. Okay, we start with our grouping symbols. We move to our exponents and square roots or radicals. We move on to multiplying and dividing, and then adding and subtracting. That's our basic form of order of operations. We've worked on those already. But now we are doing what we call inverse order of operations. Meaning we are starting at the bottom of order of operations and we're actually working our way up to the top. Now today we're only focusing on one step equations, with the exception of, I think, one problem actually is 2 steps. And so we don't really need to focus as much on going reverse order of operations because there's only one step involved. However, as we work on to 2-step equations and multi-step equations, we want to make sure that we're first canceling out the adding, subtracting. Then we cancel out the multiplying, dividing. Then the exponents. Then we get to our grouping symbols. So order of operations, although we're not necessarily using them as we did in that very first lesson, we're still using them because we're still applying them by using them in reverse. Now, what I also mean when I say inverse operations, okay, we're going to solve these. We're using inverse operations. The inverse of adding is subtracting. They cancel each other out. The inverse of multiplying is dividing. They cancel each other out. The inverse of squaring something is to square root something. They cancel or eliminate each other. So here, when I'm going to solve for x, the inverse operation of adding 5 is going to be subtracting 5. So I subtract 5 from both sides. 5 minus 5 is 0, so they go away. I'm left with x equals 8 minus 5 is 3. That is the solution. X is equal to 3. Example number 2. The inverse of subtraction. I'm subtracting 5 is to add 5 to both sides. So I have x equals, because negative 5 and positive 5 eliminate. 5 plus 7, I get 12. So if I were to substitute 12 back in for x, I would be able to simplify and I would end up with 7 equals 7. Now here's that 2-step equation I was talking about, and we'll look more at these types of problems when we get specifically to 2-step equations. This is a positive 2. This negative right here is applying to the x. Well, the opposite of a positive 2, the inverse is a negative 2. So I'm going to subtract 2 from both sides. Well, these two are going to eliminate. 2 minus 2 is 0, but I'm still left with negative x equals 5 minus 2 is 3. Well, we talked about this when we were simplifying expressions. This is really a 1 out in front, negative 1. And so these are being multiplied. We said the coefficient is being multiplied by the variable. So in order to get rid of it, the inverse of multiplying is to divide both sides by negative 1. And so x is actually equal to negative 3. So we need to be careful when we're looking at problems like this. We need to make sure we're paying attention to where the sign is. I can't tell you how many times I've seen people students try and they see this negative, so they're like, okay, add 2 to both sides. But if I were to make this an addition sign right here and add 2 to both sides, 2 plus 2, well, that gets me 4. That's not going to eliminate those 2's. That's just going to make my problem more complicated. So we really want to make sure we're paying attention to where those negatives and positives, addition, subtraction signs, where are those located? And those were our addition and subtraction examples. Let's look at multiplying and dividing. Again, that 3 is what we call a coefficient. We looked at that when we talked about simplifying expressions. Coefficients are being multiplied by the variable, so the inverse of multiplying is dividing. So we divide both sides. 3 divided by 3 is 1, but 1x is the same as just x. So we can write x equals 12 divided by 3. I get 4. Okay, problem 5. Well, this is a fraction, but a fraction is just division. The inverse of division is multiplication. So I multiply both sides by 2. These 2's are going to eliminate. I'm going to get x equals 7 times 2. I get 14. Lastly, it's a fraction. Yes, I know. When we are these, wow, this is a coefficient. 2/3 is a coefficient, just like 3 was on problem number 4. Well, coefficients are being multiplied, so the inverse operation of multiplying is to divide. But if we think back to when we first learned about multiplying and dividing fractions, if, for example, I had 3 halves divided by, let's say, 3/7, the way that I would solve this is I would keep the first thing, change the symbol to multiplication, and we say flip the second one. So I'd actually say 3 halves times 7/3. We just multiply straight across. 7 times 3, 21. 2 times 3 is 6. We would simplify because these are both divisible by 3. And we get 7/2. So when we divide by a fraction, what we are really doing is we are multiplying by what we call the reciprocal, or we flip our fraction. I've heard some people refer to it as a refliprical. That helps them remember that you're going to flip it. So when I'm doing this problem right here, I'm going to go ahead and change colors so it doesn't, actually, let's just go ahead and erase this example here. I actually encourage you when you're doing work to please don't erase your work, because then if you make a mistake on your side work, then you don't know what, and you made a mistake somewhere and that's where your mistake was, and then you erase it to make it look all nice, then you have a lot more trouble finding your mistake. So I'm not going to erase it. I'm just going to go ahead and multiply this side by the reciprocal, 3/2. So the 3's are going to cancel each other out. The 2's are going to cancel each other out. We're left with x equals. Now, multiplying fractions is probably the easiest thing that we can do with fractions. I'm going to make this a fraction by putting a 1 under it. Remember, fractions are just division. 4 divided by 1 is still 4. Multiply straight across. 4 times 3, I get 12. 1 times 2 is 2. But I need to simplify. Again, fractions are just division. I can actually just do 12 divided by 2, and I get 6. So there we go. That's it for solving one-step equations. If you guys have any questions, please let me know.